All right, so for section 3.2, we're going to mess with what we call parent functions. And then we're going to, and it's going to be about the graphs. And I uploaded notes to Blackboard about how graphs move and notes on graphs. And that will help you a lot right now if you go download those. So one of the first things that we're going to do is just discuss a few basics. So if I have y equals x to the first, your parent function is the most basic function that these things can be. So we start off with y equals x to the first, or just y equals x. And that looks like a diagonal line that slices through the origin, and if the scale is correct, it'll make a 45-degree angle. Okay. Now I can change the slope and make it steeper or flatter. I can add or subtract numbers to it, move it up or down. I can do all sorts of stuff to it, but this is your basic everyday function. So what happens if I increase my exponent? So since this is odd, I'm going to go with another odd one. So I've got y equals x to the third. And what's going to happen is that becomes steeper and it flattens out a little bit. That was lovely. Okay, it flattens out a little bit around the origin. So that blue thing is what x to the third looks like. Now, if you'll remember, this is quadrant 1, and this is quadrant 2, and quadrant 3, and quadrant 4. So I have odd exponents, and right now they're in quadrants 1 and 3, which are both odd. Okay, so it's not always going to be that way, but that's just something kind of sort of cool to note. So finally, we have y equals x to the fifth. Now what that's going to do is just make your little arms steeper. So we're going to go steeper, and then it flattens out pretty significantly around the origin. Okay, so now you pretty much know what y equals x to the 17th looks like. So if you'll notice, they all kind of sort of look pretty similar. And so just remember he's an x to the odd. So now we can go on to x to the evens. So I've got y equals x squared. And when I make a y equals x squared, he makes what we call a parabola. So he looks like this. And that's he's in quadrants 1 and 2. So don't think that an even exponent will be in 2 and 4. That's not what's going to happen. I keep yawning, sorry. All right, so we've got quadrants 1 and 2. So if I have an even exponent, they're going to be in next door quadrants. They're going to be right smack next to each other somehow. So I bet you can make a conjecture on what y equals x to the fourth looks like, because I am going to make it steeper, okay, and then it's going to flatten out, so it's going to be less of a V shape and more of a U shape, but it still has that same general shape, which means now you know what y equals x to the sixth looks like. He's going to almost box out at the bottom. Okay, so it's still that same general shape, you just really don't know which one it is unless we start plotting points. So now I know what y equals x to the odds and y equals x to the evens. So now we're going to do negative exponents. So if I have y equals x to the negative 1, that's the same thing as 1 over x. Okay, that negative exponent says flip its location in the fraction. So the negative exponent says, really and truly, I'm in x to the first, but instead of belonging in the numerator, I belong in the denominator. So this one, let's see if we can figure out what's going to happen. Up here, an odd exponent was in quadrants 1 and 3, okay? But what's going to happen here? You're going to end up having this kind of sort of punched in shape, okay? Like somebody punched it in, you can't see, somebody punched it in this way. And so if I've got variables and denominators, you're going to have some sort of push in like that, if that makes sense. It got squished. Okay, so also notice we're still in quadrants 1 and 3. But also notice with variables and denominators, I've got a gap in my graph. So I can draw this one, and then I can draw it forever and ever and ever, but then I got to pick up my pencil, and then I got to draw this one. Whereas these ones up here, I could have drawn forever. If I had enough time and enough lead, I could have drawn them forever. So this one, oh, I'm sorry, I'm trying to get these uploaded and it's 2:30 in the morning. All right, so we have, just remember variables and denominators will give you gaps in the graph. So what does x to the negative 3 look like? That's going to be the same thing as 1 over x to the third. And that's just going to be steeper and flatter, but the same basic general shape. Okay, so he'll look like that, which means now you know what y equals x to the negative 5 looks like, which would be 1 over x to the 5th. All right, so we're done with those ones. So now let's go to the evens. So if I have y equals x to the negative 2, that's the same thing as 1 over x squared. So just remember, with the x squared, not the 1 over x squared, but with the x squared, he was in next door quadrants. So this one's going to be in next door quadrants. But, that was beautiful again. Okay, but what we'll have, these are supposed to be so much prettier. All right, he's in next door quadrants, but again, he got punched in. Okay, so, and you'll have a gap in your graph. So I look at three things: variable and denominator, I got a gap in my graph. I have an even exponent, so they'll be next door to each other instead of opposite. Okay, and then the greater your exponent is, the steeper and flatter it's going to go. Okay, so I don't even need to draw 1 over x to the 4th because it's just going to have that same basic shape. So I've done all of the positive exponents, all the negative exponents, and now we're going to do fractions. So this time I'm going to start off with an x to the 1/3, which is the same thing as the cubed root of x. So how on God's green earth did I get from here to here? Math people cannot manipulate a symbol. Okay, so I can't manipulate this little house looking thing. So this is an x to the 1st power, which is what I have right here, but I'm taking a cubed root. So the cubed root, if you've got a fraction in your exponent, it means you're dealing with some sort of roots. We call it a rational exponent. So just like an x to the 3rd was tall and skinny, its opposite is a cubed root, and it's going to be short and wide. Okay, so roots will be shorter, spread out wider, but you'll notice it's an odd exponent, and I'm in opposite quadrants. So now a 5th root of x will simply be steeper and flatter, like that. So I don't know the difference in these graphs really and truly until I start plotting points. I just look at this and I think, okay, that's an x to the odd, but it's a root. Okay, so an x to the odd root. What if I have an x to the even root? And this one is going to break all of my little tricks. So remember that there's a little 2 here. We're too lazy to write it. But this one, because just like we learned, I don't want any negatives to generate under here. So he's going to have that short and wide character, but he's not going to shoot off this direction. He stops here. Okay, so he only shoots off in one direction, so he is not in next door quadrants. So that kind of ruined my little trick to remember how to do the patterns and stuff. So I've got a 4th root, and he'll be steeper and flatter. Okay, so even roots break the mold. Okay, and then we got a couple of special cases. So one of the special cases is going to be y equals absolute value of x. So we did absolute value in the last section, but what does it look like if I graph it? He will look like a V. And he also kind of sort of breaks the mold because on the inside of these bars, he's got an x to the 1st, but the absolute value makes it look like a V, and they're in next door quadrants. Okay, and then the last one is going to be, it looks like this. It's hard brackets with a vertical bar on each one. And it's going to look like stair steps or little barbells, okay? And you're finding out in this section why this graph is extremely important. So he looks like this, okay? And all of these are written out on the notes that I uploaded into Blackbaud. So you can download those, and that gives you a little hint as to what we're doing. So I'm going to spend the last couple minutes just explaining how to move them, okay? And then honestly, I really can't do much beyond that because that's what you're going to do in your homework is identify the graphs. All right, so what happens if I'm going to stretch it or compress it? If I have a coefficient will stretch or compress. So for instance, and I'm going to use the square root of x just to make life a little bit easier. So he looks like this, okay? If I give it a coefficient of, let's just say 3 times the square root of x, that's going to make him really tall that way, so it stretches him vertically, okay? It grabs him and it stretches him up. If I use a fraction here, so let's do 1/2 times the square root of x. So it's an elementary fraction. This is improper because it's 3/1, and this is a proper or elementary fraction. If I use that one, it's going to squish it or compress it. So it's going to make it long, so it's like somebody stomped on it. Okay, so coefficients will stretch or compress. What happens if I slap some negatives in there? So again, let's go back to this. I have my original function. So, and this is just y equals the square root of x. It just makes it easier for you to see if I keep using the same thing. So what happens if I slap a negative in front? What that will do is it will flip it across like it's a reflection in the water. It will not be the blue thing anymore. It will be the red thing, okay? So it reflects it. So it stops being the blue thing, and now it's the red thing. Well, what happens if I change the sign on the inside? So let's do negative x. If that negative is attached directly to the x, it's going to flip it this way, okay? If it's attached directly to the x, it's going to flip it that way. So instead of being the blue thing, like what we started with, it's going to flip it this way, like that, okay? Which, again, that was a really crappy drawing. It is 2:30 in the morning. All right. So that's what negatives do, and that's what coefficients do. The rest of what we're going to do is add and subtract. If you see addition or subtraction, that means it moves. If you'll notice, this thing was always anchored at the origin, okay? In everything that I've given you so far, it's been anchored at the origin. Well, now we're going to add and subtract, which means we're going to move it, okay? So if I just add something to the end, so square root of x, and I slap a +2 on there, if you got a +2 just hanging out, that means you're going to move up, down, and you do exactly what it says. So instead of having this one, okay, I'm going to pick it up, and I'm going to go 1, 2, drop it down, and then plot it again. So the addition subtraction actually picks it up and moves it around, okay? Now, if I want to move it left, right, I need to attach it directly to the x. So for instance, if I say y equals the square root of x minus 2, now this is what's going to throw you off. You would think go left 2. Well, that's not what's going to happen. What's going to happen is you're going to go right. So if you think this is the one time you go opposite. So first of all, notice it's attached directly to the x. This one was attached to the square root of x. So if you've got addition subtraction inside of a grouping symbol where it's attached to the x, and then this always go opposite. So I would start here, but now I'm going to go right 2 units. So 1, 2, plop it down, and there you go. So in this section, you're going to practice everything that I just taught you. And so download those notes, and that's pretty much it.